Welcome to page 4 where we're solving rational equations. And the big thing with rational equations is you want to get rid of the denominator of every fraction you have. Okay? So I'm going to go the quickest way to get rid of all denominators on these problems. Okay? So in 24, you're looking at denominators of 2k squared, 6k, and 6k squared. Well, the fastest way to get rid of them is to multiply all of them by 6k squared. Okay, so unlike adding and subtracting where we do top and bottom, here we only do the top. Okay, so 6k squared cancels out with 6k squared. 6 cancels out with the 6. K makes that just k, not k squared. Here, k squared and k squared, 6 over 2 reduces to 3. So now you've got 3 times k, 3 times 2 equals k times 1 plus k minus 3. So now simplifying, k plus k is 2k. Subtract 2k from both sides, and you get k plus 6 equals negative 3. Subtract 6 from both sides, and you get k equals negative 9. Okay? There you go. And since in here, if you put negative 9 in for k, it works. There's your solution. Okay? So 25. All right? So first off, take a look at your first fraction. The denominator is 2. So I'm going to get rid of that by multiplying everything by 2. So here, those 2's cancel out, giving us 5 plus 8 over n equals 4 over n. Now looking at the next fraction, n is the denominator. So we need to get rid of it. So I'm going to multiply everything by n, and we get 5n. Those cancel out, plus 8 equals, these n's cancel out, 4. So now to solve, subtract 8 from both sides, and you get 5n equals negative 4. Divide by 5, and n equals negative 4 fifths. Okay? And looking at our original problem, if n is 0, we'd have no solution. But we didn't, so that is our answer. 26. Okay? Looking at our first fraction, 4b squared is our denominator. So I'm going to multiply everything by 4b squared. And then here, these cancel out, leaving you with 3. Here, this b cancels out the square, and b squared cancels out with b squared. So we got 3 plus 1 times 4b is 4b, and then 3 times 4 is 12. Subtract the 3, 4b equals 9. Divide by 4, and b equals 9 fourths. All right, looking at that, only 0 would make the denominator 0, so therefore that works. All right, 27, I'm going to do it in a little bit different way, because normally we'd be factoring p squared minus 2p minus 3, but if you look, they're adding fractions with the same denominator. So all we have to do is add the tops, the bottoms stay the same, and so p plus p is 2p, and negative 2 plus 4 is plus 2. Now we have a proportion. You can cross multiply and solve this. So if we take this denominator, multiply it by 1, we get p squared minus 2p minus 3. Take this denominator times that numerator, we get p plus 1 times 2p plus 2. We get 2p squared there, 2p here, 2p here, and 2 there. So that is 2p squared plus 4p plus 2. Now solve this. It's quadratic, so get everything to one side. So I'm going to move this p squared over. I'm going to move this 2p over. And we're going to move this 3. What happens is everything over here cancels out, gives you 0. Here you get p squared plus 6p plus 5. Go ahead and factor this, and you get 0 equals p plus 5, p plus 1, which means p equals negative 5, negative 1. Now, if you look back at our original problem, if you put a negative 1 in for p right there, we'll get 0 for a denominator. That cannot happen. So our answer is just p equals negative 5. Now look at 28. Okay, if you notice, right here we've got the same denominator. So we can subtract that first fraction from that 1 over n squared plus 7n plus 12 from 6 over n squared plus 7n plus 12. So what that looks like is we would have 1 over n plus 3 equals 6 over n squared plus 7n plus 12 minus 1 over n squared plus 7n plus 12. So now we got these on the same side. So right here, the left side is going to stay the same, 1 over n plus 3, but the right side is going to be n squared plus 7n plus 12 in the denominator, and then 6 minus 1 would be 5 on top. Now we can do our cross multiplication. Take that expression times 1 would get us n squared plus 7n plus 12. Take this times 5, and that would equal 5n plus 15. Again, quadratic, move everything over. We're going to move those two pieces over. And that side all cancels out, so it becomes 0. Factor this, you get n plus 3 times n minus 1. And this would get us an answer of n equals negative 3, positive 1. But if we look at negative 3, if we put that in for that right there, we get negative 3 plus 3, which would be 0. Denominators cannot be 0. So n cannot equal negative 3, n can only equal 1. Okay, same type of deal here on 29. We see that these are exactly the same. So we want them on the same side so we can add them together. So we're going to add the 5 over b squared plus 6b plus 5 to the other side. And what that looks like is you get 1 over b squared plus 6b plus 5 plus 5 over b squared plus 6b plus 5, and that's going to equal 1 over b plus 5. And so here, adding these together, seeing that we have common denominators, we're going to do 1 plus 5 is 6 over b squared plus 6b plus 5 equals 1 over b plus 5. Now we're going to do a cross multiply. B plus 5 times 6, that's 6b plus 30 equals, we take this times 1, this is going to be b squared plus 6b plus 5. Okay, now again we have a quadratic, so let's move this 6b and the 30 over to the other side. So we get 0 equals b squared minus 25. Difference of two squareds, so that's b plus 5, b minus 5, which means we're going to get b equals negative 5 and positive 5. But if we look again, right here, If we put -5 in for b, we're going to get a denominator of 0. So -5 cannot be an answer for b, and we just get b equals 5. Okay? So, going over all 4 of these videos should be enough explanation to help you out on the test, to help get you that A that you want or you need, and help pull your grade up from the result of Mod E test. All right, thank you. Bye.